for what you've worked through. This is not anything new. This is all extraordinarily straightforward. What we're going to look at is some differences, though. When we talk about ratios, it's comparing two things. A proportion, though, get into this one, a proportion. Proportion is when you have ratio equal another ratio. In other words, fraction equal fraction. And you've done this as well. 8/12 equals, if I simplify a fraction, that's all a proportion is. 8/12, what are they both divisible by? 4. So that's the exact same thing as saying 2/3. How do you know if a proportion is true? You know that? If it works, how can you tell?
Calculator.
Okay, that helps. What's the other way?
If it's divisible by the same number.
Not quite. Cross multiply. Very good. If a proportion is true, then 2 times 12 equals 8 times 3. Does 24 equal 24? Good. Then that's right. And that's exactly what we're looking at. Fraction equal fraction, you cross multiply. Okay? Yeah. Math is fun.
No, it's just getting the test.
What we do a lot of times with similar triangles and things like that, this is where it's going to come into play. Where we're going to talk about ratios of side lengths, ratios of angles. When you see it, and you see something that says it's 2:1 or 2:3 or whatever, it's 2/1. And that's how it works. And you just keep consistently going through it. If you look at letters, here they say A, B, C, D, E, F. So when you start thinking about the ratios of sides, just like we did before with congruency statements, similarity statements work the same. You just gotta keep your letters straight. For example, if we had triangles ABC and DEF, I would say AB is to BC is to CD. Notice I just put the letters in order of the segments, and I do the exact same thing with the corresponding other triangle. Was it DE? That's all it is. The lettering corresponds to make a fraction. That's it.
It's at the end. Right?
Oh, it's CA. It's supposed to be CA also. And FD. Yeah, we can do that. Now, the idea here is that just as long as your side lengths match up, it'll work. Okay, and that's how we're going to be able to work with these things. And we do this kind of over and over and over again throughout this whole chapter. Is you're going to write out a statement, fill in the blanks, and go. Okay, there's not a lot of craziness here. You see how it works with just the same thing as congruency? It's just a fraction. Nothing to be afraid of. When you simplify things, if you're dealing with ratios, what is the one thing you have to have in common? Units. Very good, yes. Units. When you do this, you have to have units that are correct. One of the other things that happens a lot of times with this stuff is that we no longer use mixed numbers. Okay, we don't say 2.5 or 3 5/7. We don't do that. We use improper fractions, which can be top-heavy. We use those all the time. It's easier to work with. It's also one of the reasons why we use slopes. We never use slopes as mixed numbers. We don't use mixed numbers really at all in Algebra 2. There's maybe one time that it's easy to count with, but other than that, we don't use them. They kind of cease to exist.
No, the point of learning that.
There's reasons that you have them, but when you start multiplying, adding, and doing all this other stuff with more math with them, it's just so much easier not to use them. Because you have to have the common denominators and all that other, it's just easier. So 60 over 51, can it be simplified? No. So it's done. That's the simplest terms. Now the other one though, it's in centimeters and in millimeters. Yeah, they gotta go to the same unit. Now, when you're dealing with units of measure, it is easier to move up in units or down? Down. It's easier to go to the smaller of the two units. If you think about it, if you have 3 feet is to 40 inches. It's easier to convert feet to inches just by multiplying it by how much? 12, okay? Because if I take 40 inches and divide it by, then I'd have to divide it by 12, I'm gonna get decimals, okay? It's always easier to move to the smaller of the two units of measure. So I would say this would be 36 inches to 40 inches, and then I can simplify that fraction, and so on. I think I can divide both these by 4, and I get 9/10. 9 to 10 would be the ratio, okay? Same deal here, centimeters and millimeters. Don't really live in Europe, so I really don't know a lot about the metric system. I do believe it's, you just multiply that by what, 10? Or is it 100? It's 10, right?
Yes,
Yeah.
10.
So this would be the same as 70 over 14, and then you would simplify that fraction. Okay? You'd simplify the fraction. In the calculator, you just type 70 over 15 and it spits out the answer. I believe you get 10 over 2, so it's 5 to 1. And that's what you would write. Okay? The ratio would be 5 to 1. When you have ratios, if the denominator is 1, you usually throw that in there. Okay? Because it just says it's 5 to 1. Same thing here. This is where we throw it into a little bit of algebra. Angles. In a triangle, what do all three angles have to add up to equal?
180.
180. So if they say that they're in this ratio of 5, 9, and 16, if the three angles in a triangle have this ratio of 5, 9, and 16, we need to figure out their measurements. Well, this works every single time for when you're doing, dealing with an angle. If there's some ratio, these are some common multiplier. We just don't know what that number is. So we don't know what something is in math, what do we call it? Or we represent it as? X. So if you're in the ratio of 5, 9, 16, we know that there's 3 of them. They have to add up to equal 180. Well, all you do is this. 5x, 9x, 16x. We're trying to find that common multiplier. We're trying to find that common x value. That makes it work. Okay? And this will work with whenever you deal with angle measures, whether it's in a triangle, any other polygon as we get further on, we use the same basic idea. We just have to add up to whatever the degree measure is going to be. So what's 5, 9, and 16 equal? 30. 30? And divide it out, what do you get? 6. So that means that common multiplier for all of them was 6, which means you can then figure out the 3 angle measures. 5 times 6, 9 times 6, and 16 times 6. 30, 54, and 96, I believe. That's how that works. It's not too bad for a Monday morning, right?
No, it's pretty bad.
Everything's bad for you, Whiskey, everything. Oh, excuse me.
Well, I'm really sorry, but I'm stuck in school. I'm sorry. I'm sure it's not supposed to.
You'll get over it though, right?
I have 2 more years plus another 4 years.
And then you'll get over it by then. So, as we go on, hey,
Somebody's late.
we good? All right, so then we get into doing stuff like this. X over 8 is 5 over 4. Gee, what do you think we're going to do?
Cross multiply.
Yep. Cross multiply. Yep. That's it. Yeah, we just cross multiply. It's that fast. Okay. That's all it works out to be. Now, it's not always going to be that fast. Sometimes you might actually have to use the distributive property. I know we are asking a lot here today.
What's so funny, Mr. Murphy?
Do I have to say it? These are too easy. Oh,
Do it easy.
yeah, all right. Take a minute to do those.
All right, yes,
This
sir.
will take a whole lot, 6 or 7 seconds, I can imagine. Excuse me. Sit there and shovel and do everything. We're not like that in cul-de-sac fights, so there's only like 4 people living there so far. So they're still building up all the houses. They did. Once. I think they came around the last time, but yeah. Slow as not fun. It's better than none. I don't know. Once you do, I just show up. Yep. Hey, did you guys ever do it this way? Obviously, this is 3x equals 5 times 12. You everybody agree with that? Now, if I just do this right away, do you know you can type that in your calculator like that, and it'll just give you the answer?
It's more buttons to press.
Is it the same amount of buttons, really?
I don't know. I tried it yet.
Or you just simplify this and do that and get 20?
There's
Simplify the fraction before you do it. And you can do that as well. So let's see, 7 times 30 is 6x, divided by 6. This becomes a 5 and you get 35. Or press buttons in the calculator, you get the same thing. Go over what? Cross multiply. Fraction, cross multiply. That's all it is. The narrow,
Okay, go over just the 8 12.
the what?
The first one, number 4.
What's 5 times 12? 60.
6.
What's 60 divided by 3?
5.
That's all I'm doing. I'm just simplifying before I go. So 3x is 9 times 7
why?
divided by 3. I get 21.
Wait, that's the word for
Yes, a lot of times they change the variables on you all the time. It's just habit for me to use x over and over. I just do that all the time. Yes, sir. Yeah, it's fine. I'm probably gonna have x on there anyway, so it's not a big deal. Yes, sir.
How did you get 3x plus 9 times 7?
I cross multiply. Fraction equal fraction. You cross multiply.
Oh.
Mr. Murphy?
Yes, ma'am.
Okay, since you said you didn't know the metric system, are we gonna put on the test?
The what?
The metric system?
I
Are
don't
we gonna have that to it?
I probably usually go. I usually, if I switch between stuff like that, I usually keep it with feet and inches, or yards and feet, even miles. You guys know how many feet are a mile?
5,000.
5,200.
5,280 feet in a mile. That's something you kind of need to know.
Wait, what?
That's a like
Feet,
number.
yeah. You need to know how many feet are in a yard.
Three.
Three.
And then there are 5,280 feet in a mile. That's about the only ones. Usually
How about
when we go
yards in a
through
mile?
that,
1,760.
Wait, how am I getting it again?
Yards in a mile.
I don't think I've ever done that way. It's usually feet.
1,760 yards in a mile. I just looked at it. I just looked at it.
This is the new part. This is called the geometric mean. This is the new thing. The geometric mean is something that we show you guys now, and then we use it in triangles more so second semester. There are similar triangles that deal with right triangles. We talk very little about them, but we do. Well, we might do a little bit more. I don't know. I haven't decided yet. Second semester, it's still a month away. But geometric mean is just going to be something like this, where it's always some fraction equal fraction, but the variable is double. I don't mean double, but you use the same variable twice. Like that. So when you cross multiply, you're always going to get an x squared. Excuse me. Whereas the other ones are going to be just numbers, 4 and a 3. This would be x is the geometric mean between 4 and 3, is what I would say. If it ever asks you to find the geometric mean between 5 and 3, you just write as 5 over x is x over 3. That x will always be on the diagonal. So you get x squared. Now all you do is, obviously I'm showing a hint here, you have to simplify radical. You get, x squared is 12. Now, you type that in the calculator, you're going to get a simplified radical form. Because how do you undo? Yeah, you gotta have this one. How do you undo squaring? You guys remember? Square root. So in your calculator, you would type in the square root of 12.
Which is
And your calculator should spit out 2 root 3. That's what we call simplified radical form. If your calculator does not spit out 2 root 3, you need to have a calculator that spits out 2 root 3. There are no such thing as decimals. Plain and simple. It's going to be simplified radical form for these types of answers. There are no decimals. Okay? So if you don't have one of those calculators, we have plenty of them, or you're going to have to remember how to simplify radicals. Okay? Which is a pain, but you can do it. Because when you're dealing with square roots, you're looking for what are called perfect squares,
Oh, now I gotta make a new one.
and so on and so on. And you're trying to write out the square root of 12 as a product of perfect squares. Well, a perfect square that goes into 12 is what? 4. And what's the square root of 4? That's how you get 2 root 3 out of these. Okay? You need to make sure you have that calculator. That is a huge, huge thing. You have to have that calculator because when we get to second semester, even more so, we're going to deal with 45, 45, 90s, and 30, 60, 90 triangles. And these all have ratios with square roots in them. In working with these square roots, you have to leave your answers in what are called simplified radical form. It's what we call an exact answer. Because then when you get to algebra 2, you still leave them in simplified radical form and you work through them. So just so you guys know, you don't have that calculator, you've got to get it, okay? You have to have it. So, how do we write out, find the geometric mean of 45 and 5? There it is.
Does it matter?
As long as they're in a diagonal, it's fine. X's are always diagonal from one another. Okay? You can have it that way, or like you were saying, you can go this way too. As long as they're diagonal, but usually it's easier to do it 45 is to X is to 5, because they're giving you the two end numbers. So you start with this number, you end with this one, and these are in the middle. It's easier to think of it that way. Yes, sir.
Okay, so would it be wrong, like, if that's the question, 45 comes first, but you write it like 5 on the left, or is it wrong?
Because what 45 times 5 is the same thing as 5 times 45. So we multiply that out, you get x squared is, what is that? What is it, 225? And what's the square root of 225?
15.
15. Okay. Because 45 divided by 15 is the same thing as 15 divided by 5. It works out to be 3. What you're looking at is what can you divide by one number by, and what can that number be divided by to equal the same ratio. That's what a geometric mean does. Okay? It simplifies out to give you the same ratio overall. Not too bad. Let's just press some buttons. Let me show you the other little algorithm here real quick. Before I get to the perimeter one. Sometimes they will give you solve a proportion where you have multiple steps on the equations. But it's just a matter of writing it out and distributing correctly, and it doesn't work out too terribly. So I have x over 24 is x minus 12 over 8. So you have to write it out. 8x is 24 times the quantity, that. That's where you guys will forget it. You'll forget to send it to both parts. Okay? Whenever you guys see distributive property for some odd reason, we tend to forget to distribute to both pieces. So, don't do that. Excuse me. Draw your arrows and write it out. 243, 308?
288.
I was close. I knew it ended in 8. And now you had a two-step equation. Subtract the 8x, add the 288. And let's see, what did we wind up with? 18. So there you go. It's not that the algebra is difficult, because you still have your calculators. It's just a matter of remembering how to distribute the thing. Okay? That's usually where people forget. That's why I wanted to show you an example of that first. All right. All right. Let me show you the other little new thing that we can do. I know, right?
I thought we had enough of quick things.
Nope.
Okay.
So let's say we have, oops, that didn't work. Let's say we're given the perimeter of a rectangle, and we know the ratio of the sides, length to width, is 8 to 1. So let's figure out how we would write this up. Excuse me.
It is already written 8 to 1.
Yeah, right?
Is the question then what are the lengths of the sides?
Yeah.
Okay.
And this is
It never said that before.
well, I hadn't gotten that far yet.
Uh,
So, perimeter of a rectangle, if we do the perimeter of a rectangle, excuse me, how do you find that?
Right into one.
What is perimeter again? That's area.
Perimeter is
We're adding
all the
stuff
way
in.
around.
Okay. So you have length, width, and width, right? So if I'm doing the perimeter, isn't the perimeter twice the length plus twice the width?
Yeah.
Okay. Now, when we go off of that, we have this weird ratio that we have to mess with. Excuse me. We have the weird ratio to mess with. So how do you think you're going to set that up with the perimeters?
So you're going to do 2 times 8 equals 2 times 1.
2 times 8 is 2 times 1?
So you're saying 2 times the length should equal 2 times the width? What? So you're saying,
No,
No, you gotta add them.
16 equals 2.
think about
Yeah, that's what somebody get it.
that. Okay.
16 equals 2.
Sorry, no worries. So, what did we do earlier when we had the triangle stuff? Remember we did that? We had the angles, where it was 5, 9, and 16. We knew that there was some common value between all of them, so it was 5x, 9x.
So we just to equal those to 36.
Close-ish, but we have to keep this value here.
Okay, so we go 36 equals 2 times
36 equals 2 times blah, oops, plus 2 times blah.
Wait, what?
Okay.
Because I said
Where did you get the 36 from?
36
The perimeter.
Oh!
So notice, just like we did earlier when we had the angles thing, we basically threw an x value into them. What's different here is that perimeter has a formula. It's 2 times that. Okay. So what's 2 times 8?
2 times 8 is 16.
16, and 2 times 1 is 2. So we have 36 equals 16x plus 2x, which is 36 is 18x. What's x?
Divided by 18.
See how that works? The idea is that we're still using that same kind of same process of throwing an x value in on the ratio, but you have to remember that we have this 2 out in front of it for the perimeter to work. Now you can do it another way as well if you wanted to. Bless you. If you knew that, if you think about when we had our triangle stuff, if this was 1x, this was 1x, this is 8x, and this is 8x. You can do the exact same thing. 8, 8, 1, and 1. So that's up to equal 18. So your value of x is 2. What are your side lengths? Well, I have a side length of 16 and a side length of 2. There you go.
Yeah.
He gets there sometime.
Of course I was.
Let's try another one. Excuse me. Now they usually do these with rectangles for the perimeter stuff because it's an easy formula to remember. And it's something you guys have done before. So if I have a perimeter of 50, ratios of the sides are 3 to 2. So your perimeter, twice the length plus twice the width. Our ratios are 3 to 2. So it's 50 is twice the 3x plus twice the 2x. So 50 is what, 6x and 4x, otherwise known as, and what's x? So if 5 is your x, what are your side lengths?
32.
Sorry.
Times.
Remember. So it's 3 ratios, so length and width is 3x and 2x. If x is 5, our sides are 10 and 15. It looks a lot like it's going to be a lot more complicated than it is. But it's not. Okay? It's kind of, you kind of see this pattern quite often with this stuff, that it looks like it's going to be awful, but it works out real fast. Okay? Me? I don't think there's anything else goofy with this.
No. I said no.
Do I have to show you guys how to count on a number line?
Yeah.
I mean, honestly, we all know that there's.
I'm going to leave this one up to you.
I only know alphabet.
This. What's that? Really? So, let's see if we can figure this out then. You probably don't have to draw this, but how far apart is A and B? Well, let's count. 1, little 2.
1, little 2, little 3.
Obviously, you can't count because it's only 2.
Well, that's how I was taught. By
You're
Mr. Judkins.
So it's 2 over, well, let's count the other one. Ready? 1, little 2, little 3, little spots. 4, little 5, little 6. What's the ratio?
1 over 3.
That's it. I'm assuming you guys can do that.
No.
It's way too hard.
You just want to sing.
Wait, did people like learn to count?
What's that?
Did you actually learn to count?
Of course, didn't
I
you?
didn't learn to count. I learned in Spanish.
Uno poquito, dos poquito, tres poquito, numeros. Little.
Worse.
It doesn't. My singing in Spanish isn't all that great. No es bueno.
I don't even know the song.
No, he just saying 1 little 2.
Okay, it's un poquito, dos poquitos, tres poquitos, I don't even know how to say it.
I see. It's all. It doesn't sound as cool as. It doesn't sound as good as it is.
Yeah, it doesn't sound as good.
It doesn't flow.
Yeah, you gotta
Speak English.
Oh, yeah. Hey, do these. This should not take long. The tab is open. I put since we're starting chapter 6, the tab is there in the chapter 6 part of the website. Remember, chapters 5 and 6 are the ones that are on the same PDF file. So it does. You just have to scroll through 5 to get into it. That's all. You'll find it.
Last year I had like this whole entire thing, like the notebook just like was full by the end of the semester, and I only have like 1/3 of this.
Really?
Yeah.
Huh. Well, we do a lot of notes and stuff like that, but a lot of our stuff was.
It was like the groups and stuff.
Yeah, and that was a lot of that built into the progression sheet, which in and of itself was a giant sheet of notes. So.
We did a lot of notebooks.
Are the test grades in Skyrim?
I just put them in this.